Today's topic is Lechatelier's principle. Lechatelier's principle basically says that if a dynamic equilibrium is disturbed by changing the conditions. And which conditions am I talking about? I'm talking about temperature, I'm talking about pressure, and I'm talking about the concentrations of reactant or product at equilibrium. All right. So if dynamic equilibrium is disturbed by changing the condition or the conditions, the Lechatelier's principle says that the equilibrium position, which was initially 50% forward and 50% backwards, will move in such a way, as to counteract that change, at that change. All right. So if you disturb dynamic equilibrium by changing any of these conditions, what will the equilibrium do? According to Le Chatelier's principle, it will counteract that change and it will move in such a way that it has to counteract that change. It will oppose that change. All right. So if I increase temperature, this is what I did. So let's write us. What will equilibrium do? It will counteract that, right? So it will do what? It will try to decrease temperature and take it back onto the equilibrium temperature. If I decrease the temperature from outside, what will the equilibrium do? It will increase the temperature again. The equilibrium will increase the temperature. Similarly, if I decrease the pressure, what should equilibrium do? It will do the opposite thing always. It will try to increase the pressure. If I increase the pressure, equilibrium will try to decrease the pressure. All right. And same goes for concentration. If I increase the concentration of a reactant or a product, what would equilibrium do? Equilibrium will try to decrease the concentration of that reactant and product and take it back onto the equilibrium concentration. All right. And if I decrease concentrations, equilibrium will try to increase the concentration. Now we do know that equilibrium is counteracting everything that we've done, but how does it do that? Any ideas? How does equilibrium counteract the changes?
It could
Yep.
maybe change the other ones, like maybe if temperature is affected,
Nope.
it lowers the temperature by maybe the pressure and the concentration.
No, no. There's no relationship between any of these. All right. So what equilibrium can do, it can only try to change the position of equilibrium. Right now, the position of equilibrium is equally distributed forward and backward, right? The only way this equilibrium can actually create a change, there's only one way. It can either move forward in the forward direction or either move backwards. It can either conduct the forward reaction more than the backward reaction and or the backward reaction more than the forward reaction. There's only these two ways in which it can change or counteract any change that I've created. All right. So it can either go to the right hand side or it can either go to the left hand side.
Okay.
Can you hear me?
Yeah, I can.
So equilibrium can only create a change by either going to the right hand side or to the left hand side. Now that doesn't mean that the backward or forward reactions stop happening. What happens is that, for instance, to counteract, equilibrium might have to go more to the right hand side than to the left hand side. This dynamic equilibrium changes its position. Now it's going more to the forward direction and less to the backward direction. Or the other way around, what it does is it goes less forward and more backward. It could be like this. All right, but there's only this way in which equilibrium can actually counteract any change that we create. It's either it will move towards the forward direction or move backwards. This is the only way. All right. So it has no other way of creating change at equilibrium itself. Are we clear? So
Yep.
now using the principle, the Lechatelier's principle, let's first do the factor of equilibrium that affects equilibrium, which is, let's start with concentration. All right. So let's start with factors that affect equilibrium. Now do know that in our syllabus, we'll always considering the equilibrium initially to be dynamic equilibrium, and we'll always be disturbing a dynamic equilibrium, not any other equilibriums. All right. So the first factor is concentration of reactant or product. So I'm going to take a reaction as just an example reaction that A plus 2B goes into C plus D. This is a reaction. It is at dynamic equilibrium initially. All right. So let's say the reaction is at dynamic equilibrium. What does that mean? That is going 50% forward and 50% backwards, or the rate of forward and backward reaction are equal right now, right? Now, what do I do? From outside, I'm going to come in and disturb this equilibrium. How do I do that? I can do that by changing the concentration of any reactant. Now, what can that change be? I can either increase the concentration or decrease the concentration. So let's start with increasing the concentration of this reactant, A. So the first case would be, what happens if we increase the concentration of A, which is a reactant over here? Now let me copy that equation again. Now, this reaction was initially at dynamic equilibrium, right? So if I disturb this equilibrium by increasing the concentration of A, what is equilibrium supposed to do? I increase
If
the
concentration
concentration.
increases, it's supposed to decrease it, right?
Yeah. I increase the concentration of A. Equilibrium is supposed to counteract that change. What is equilibrium supposed to do? Equilibrium will try to decrease the concentration of A, right? And how will equilibrium decrease the concentration of A? Will it start spitting out A from the reaction mixture? No. There's only one way that equilibrium can actually counteract the change, and that is either by going right hand side or left hand side, right? It can either move more forward or more backward compared to the previous dynamic equilibrium. So now, if equilibrium wants to decrease the concentration of A, it wants A to go back to the equilibrium concentration. What should it do? It will start, it will shift towards which side? Towards the right hand side. Because if equilibrium shifts towards the right hand side, what happens? A starts getting consumed, B starts getting consumed in the forward reaction, and C and D are produced, right? And in this way, when it moves towards the right hand direction, what happens is that all the extra A that came in, it all starts getting consumed and converted into products. Is that clear?
Yep.
So A, in order to counteract the increase of the concentration of A, it has to decrease concentration of A, and it has only one way. It can either go right hand side or left hand side. So it wants to decrease A. What does it do? It makes A react with B and go into C plus D, the products. So that's the way it's going to actually decrease the concentration of A again. All right. So it shifts towards the right hand side. Are we clear?
Yep.
All right. So I can say that, let's try to explain this explanation. All right, that when we increase the concentration of A, equilibrium will counteract to decrease it. In order to do so, it shifts towards the right hand side, towards the right hand side, so that A is consumed and products are formed. All right.
Yep.
What if I increase the concentration of B? Let's do that also. Let's do this in detail. What if we increase the concentration of B? What should happen? Let me duplicate this. Yep. So if I come from outside and add more B onto this equilibrium, this dynamic equilibrium was disturbed. Now equilibrium wants to counteract any change that you've created. So what should equilibrium do? Equilibrium now wants to do what? Equilibrium wants to decrease B. So in order to decrease B, which direction should it go? Should it go into the right direction in which B is being consumed, or the left direction where B starts being formed, or more B is starting to being formed?
To the
Which
right, so that
direction?
it gets
Yeah, it should
consumed.
shift to the right hand side again in order to decrease the any extra B that came on from outside. All right. So the same thing, right hand side. So now I'm not going to write everything. We'll just say equilibrium will shift to the right hand side to decrease the concentration of B. Now let's see what happens if we increase the concentration of C. That is a product that's on the product side. What happens when we increase the concentration of C? Now C is on the product side, right? It's one of the
Yep.
products in this equilibrium. So if I increase the concentration of C, I add more C from the outside, what is going to happen? So now what I've done is this reaction was at equilibrium and I came in and I increased the concentration of C at equilibrium. Now if the concentration of C has been increased by us, what should equilibrium do? It will
Decrease it.
decrease the concentration of C. Now in order to decrease the concentration of C, which side should the equilibrium shift to? Should it shift towards the right, due to which more C and D will be formed, or should it move towards the left where C is consumed and A and B are formed, C and D are consumed?
To the left.
Yes, it should go to the left because it wants to decrease the concentration of C. So in order to do that, it shifts to the left hand side. So more C is consumed and more A and B are formed, right? So it shifts to the left hand side in this case. So equilibrium will shift to the left hand side in order to decrease concentration of C. All right. And do I have to do it for D now? If I increase the concentration of D, what do you think equilibrium should do in order to counteract the change? So you'll think like this. If I have increased the concentration of D, what should equilibrium be doing?
Going to the left.
It should be decreasing the concentration. First, you have to figure that out, what equilibrium has to do. If I've increased the concentration, equilibrium has to decrease the concentration again, right? And in
Yep.
order to do that, where should it move? That's what you ask yourself every single time. So in order to do that, it has to move to the left-hand side. So D is consumed and more A and B are formed. All right.
Yep.
Now I'll do one on the product side and one on the reactant side for the decrease in concentration. So what if we decrease the concentration of, let's say, A? Then what happens at equilibrium?
Increase the concentration of A.
Yep.
Then it would move to the right. We have to decrease it.
We have decreased the concentration of A, not in.
Oh, okay. So then it would move to the left
Let's see.
to create more.
So what have we done? We came in and disturbed the dynamic equilibrium by decreasing the concentration of A. Now, what is equilibrium supposed to do? It's supposed to counteract, right? So if we decrease the concentration of A, equilibrium has to increase the concentration of A, right? And in order to increase A, what should it do? Should it move to the right-hand side where A is being consumed and it decreases furthermore? Or should it move to the left-hand side where C and D will react together and produce more A?
The left.
Yeah, it should move towards the left-hand side. So it will move towards the left-hand side and more A will be produced in order to increase its concentration, right? So this is just this is all about concentrations factor at equilibrium. It's that simple. So let's say equilibrium position will shift to the left-hand side in order to increase the concentration of A. All right.
Yep.
All right. So the next thing would be, what if we decrease the concentration of D? What if I decrease the concentration of D at equilibrium? So let's see what happens. So now this reaction was at dynamic equilibrium. What I did was I decreased the concentration of D. What is equilibrium supposed to do according to Lechatelier's principle? It will try to increase the concentration of D again, right?
Yep.
So in order to do that, should it go to the left-hand side? During that process, D will be consumed, C will be consumed, or should it move to the right-hand side in which A and B react and produce more D? Because equilibrium wants to increase D. Should it go to the left or should it go to the right? Yep.
It should go to the right.
Yeah, it should be going to the right-hand side. So more D is produced because because the equilibrium wants to increase the concentration of D, right? So it moves to the right-hand side. So equilibrium will shift towards the right-hand side in order to increase the concentration of D. All right.
Yep.
Now there's also another thing that you need to understand, that when equilibrium is shifting to the right-hand side, what does that mean? That it's conducting the forward reaction more than the backward reaction in this case. All right. So we can say that the rate of forward reaction increases and the rate of backward reaction decreases. All right.
Yep.
Okay. So this was all about the concentration factor. The next factor that we have to discuss will be temperature. Factor number 2 is, let's write it like this. Factor number 2 is temperature. How does temperature affect equilibrium? Let me write effect of temperature on equilibrium. So effect of temperature on equilibrium. Now remember that for temperature, you need to first learn what are the things that you need to know about the reaction that is at equilibrium. All right. So in order to figure out what happens when you increase or decrease temperature, what you need to know is we need to know if the forward reaction is exothermic or endothermic. All right. We need to know that. Otherwise, we cannot figure out what will happen at equilibrium. So let's take the same reaction A plus B plus A plus 2B goes into C plus D. Now remember that whenever you have a reversible reaction and there's a delta H or enthalpy change written in front of it, this enthalpy change would always be for the forward reaction. All right. So if the delta H written in front of this reversible reaction is delta H is positive, for example, positive 200 kilojoules or positive 1000 kilojoules, whatever, but it's a positive value. What does this mean? This delta H is always for forward reaction. All right. It's always for forward reaction. So this delta H is telling us that this forward reaction is what? It is positive. So what does that mean? Delta H is positive, enthalpy change is positive. It is endothermic.
Endothermic.
Yep. And the opposite reaction is the opposite of the process, right? The backward reaction is the exact opposite of this process. So that would be the exact opposite change, that is exothermic. If the forward reaction is endo, the backward reaction, which is the complete opposite of that, would be exothermic. All right.
Yep.
After you've written this, what I need you to do is I also need you to, now I call this the working that you need to do before deciding anything about equilibrium. Now first you look at the enthalpy change. It was positive, so I labeled the forward reaction as endothermic and the backward reaction as exothermic. Now I know that the forward reaction is endothermic. What should happen to the temperature of the surrounding if a reaction is endothermic or by an endothermic process?
It
What
should get
happens?
colder.
Yep. So temperature decreases, right?
Yep.
Because endothermic heat energy is absorbed. So the surrounding temperature will start decreasing. What about the backward process? It is exothermic. It will release energy. So the temperature of the surrounding will increase, right? This is all the working I need you to do before deciding whether temperature will shift the equilibrium right or left. This is the working I need you to do before that. Now you'll see how easy it gets. So if at equilibrium, what if we increase the temperature? Now remember that we can only increase the temperature of the surrounding, not the system. The system is that equilibrium reaction. You cannot go into the system and try to increase the temperature. You can only increase the temperature of the surroundings in which this reaction is happening or decrease the temperature of the surroundings. For example, this reaction is happening in a beaker or in water. I would only be able to increase or decrease the temperature of water by heating it, right? I cannot go in and increase temperature of A, the reactant, or B, the reactant, or C or D, which are the products. I can only increase or decrease the temperature of the medium inside which this reaction is happening. All right. So what
Yep.
if we increase the temperature? What should be happening? Now, if we increase the temperature, what is equilibrium going to try to do? Now let's write
Decrease
it.
temperature.
We increase the temperature. What is equilibrium going to do? Equilibrium will try to decrease the temperature. Now, in order to decrease the temperature, where should the equilibrium shift towards in this endothermic reaction? Should it shift towards the right-hand side, which is endothermic and decreases the temperature, or towards the left-hand side, which will increase the temperature again?
The right-hand side.
Yep, right-hand side. So that's how this working is going to help you a lot, right? So in an instant, you were able to know which direction the equilibrium will shift towards. So I'll label the equilibrium shift with the highlighter. What the equilibrium needs to do is decrease temperature, and we saw that increase temperature will be decreased when you shift towards the right-hand side. So in this case, the equilibrium will go towards the right-hand side in order to decrease temperature, because the right-hand side or the forward reaction, it is which type of reaction? This forward reaction. It is endothermic, and in endothermic reactions, the temperature of the surrounding starts to decrease, cools down. So we increase the temperature in order to decrease that temperature or cool down that temperature. What does equilibrium do? Again, it has only one way, either go right or left. So it started going towards the right in order to decrease temperature. So I label that shift over here. So equilibrium move towards the right hand side. All right. So it shifts to
Yep.
the right hand side and favors which reaction? The endothermic reaction or the exothermic reaction? Which
The
reaction is favored?
endothermic.
The endothermic reaction is favored in order to decrease temperature again. All right. So that's how I'll try to explain this. So when we increase the temperature, the equilibrium position will shift to the right hand side, and favor the endothermic thermic forward reaction, or just the endothermic reaction, in order to do what? Decrease the temperature. All right. So it's that easy if you're able to write these things, do the working for temperature. Are we clear?
Yep.
Now let's do this reaction was again, I'm still going to keep it endothermic. So what was the working that you need to see? If the question is about how temperature is affecting the equilibrium, the first thing that you need to do is identify what's the forward reaction. It's positive, that means endothermic. So this forward reaction is endo, and the backward reaction is exo, which is the opposite reaction. It is exo. All right. And then you have to
Yep.
decide what happens to temperature when I go forward and backward. Endothermic reactions absorb heat energy from the surrounding. What should happen to the temperature of the surrounding? It should decrease by
Decrease.
this endothermic reaction. And by the exothermic reaction, because it is going to release heat, what should happen? The temperature should, for the
Increase.
surrounding, increase. Now this is the working I've done. Now the next part that I'm going to ask is, what if we decrease the temperature in this endothermic reaction?
Then it should go to the left.
Yeah, then it will go to the left, because now I can clearly see that if we decrease the temperature, equilibrium wants to increase in order to counteract. And the only way to increase the temperature is go towards the left hand side, right? And favor which reaction? The exothermic reaction, in order to increase the temperature again.
Yep.
It's easy, right?
Yep.
So I'm going to explain. So if we increase the temperature, equilibrium will shift towards the left hand side and favor which reaction?
The exothermic.
Yep, the exothermic reaction. Exothermic reaction in order to increase the temperature. Yeah,
Yep.
so it's really easy. And the other case for it would be if the forward reaction is exothermic. This reaction was endothermic in the forward direction. What if there's another reaction which is exothermic in the forward direction? Then its backward reaction would be endothermic, and then you'll have to decide again. So let's take another reaction. Let's say P plus Q goes into S plus R. And this reaction has a delta H which is negative. Now remember that this delta H is always for which reaction? The forward or the backward?
The forward.
It's always for the forward reaction in reversible reactions. So this forward reaction would be exo in this case, and the backward reaction would be endo in this case, right? So what should happen in the forward reaction to the temperature of the surrounding?
It increases.
And what should happen in the reverse reaction?
Decreases.
Now I know these two things, I can instantly tell which position the equilibrium is going to shift. All right. So what if we increase the temperature at equilibrium? So I came in, I increased the temperature. What should happen? Equilibrium will try to decrease the temperature. In order to decrease the temperature, which side or which reaction should the equilibrium favor?
The left.
Yeah, the left side. Which reaction is that?
The endothermic.
Exactly. So now I know which direction equilibrium is going to shift.
Yeah.
So it's going to take towards the left-hand side in order to decrease temperature again and favor the endothermic reaction. So let's just write the equilibrium will shift towards the left-hand side and favor the backward reaction. Sorry, favor the backward endothermic reaction or just the endothermic reaction. Okay. Now let's do the last one orally. I want you to make an answer for this. What if we decrease the temperature at equilibrium? Yep. If I decrease the temperature at equilibrium, what
Then the
happens?
reaction would move to the right-hand side,
Yeah,
and the reaction would be exothermic, so that the
it
temperature
will
could
favor the
increase.
exothermic forward reaction in order to increase the temperature.
Yeah.
Right? So in your answers, what you have to mention is always talk about the position of equilibrium. Is it going towards the left-hand side? Is it going towards the right-hand side? And why is it doing that? These two things are very important whenever you're answering about the position of equilibrium or what the effect on equilibrium will be if you change any of the conditions. All right. So the direction of equilibrium that should be included in your answer and why is it doing that? So he said it's going to move to the right hand side. That's the direction. Why is it going to move to the right hand side?
To increase the temperature.
Yeah, because the right hand side or the forward direction is the exothermic reaction, which will then in return increase the temperature. All right.
Yeah.
So equilibrium will shift towards the right hand side. Now that's the direction and favor the exothermic reaction. Exothermic reaction, which does what? In order to increase the temperature. Okay.
Yep.
Okay. So do remember what working you needed for concentrations in order to talk about concentration and what working you needed for discussing temperature at equilibrium. All right. When we were talking about concentrations, we did none of these workings, right? We only considered if I increase this, what should be the reaction of equilibrium at this point? It should try to decrease this, right? And in order to decrease, which direction is it willing to go? But whenever you're talking about temperature at equilibrium, first you need to label all these things. The forward reaction is endo and the backward reaction would be exo. What happens in the endo reaction to the temperature of the surrounding and what happens to the backward reaction to the temperature of surrounding. All right. Once you've labeled all this, then it's very easy to figure out where the direction of equilibrium would be. Our last factor is effect of pressure at equilibrium. So if I disturb dynamic equilibrium by changing the pressure, what should happen to that equilibrium? Or which position should that equilibrium move on to? So let's take another example. Remember that this factor is only for gaseous phase reactions. Because increasing or decreasing temperature does not really affect liquids or solids that much, right? It's a very minute effect. So it's insignificant. But for gases, pressure plays a very important role. So remember that this factor is only in the cases of gaseous phase reaction. You have a gaseous phase reaction, then pressure will affect that equilibrium. All right.
Yep.
So if I have the reaction A plus 2B goes into C plus D, and all of these things are solid, will pressure have any effect on this equilibrium?
No.
No. But if all of these are gaseous, all of them are gases, then pressure does affect this equilibrium. All right.
Yep.
Now, for pressure, what working you need to do is you need to figure out the moles of gases on the reactant side and the moles of gases on the product side. And what's the reason for that? We'll talk about that later. But what are the total moles of gases on the reactant side? There's 1 mole of A and there's 2 moles of B. So there's 3 mole of gases, right? On the left-hand side. And how many moles of gases are on the right-hand side? There's
2.
2 mole of gas on the right-hand side. So if I move on to the right-hand side, I produce 2 moles of gas. If I move to the left-hand side, I produce 3 moles of gas. Now remember that so I was talking about if you have a container and you have a gas inside the container, how do you think the pressure inside the gas is built? Sorry, inside the container is built. Pressure
By
is,
hitting the walls of the container?
pressure is the force upon area, right? So these
Yep.
molecules, the gas molecules inside the container, they're moving randomly. And during this random motion, what do? They collide with the walls of the container and apply a force on the area of the container, right? This causes a pressure to be built inside this container. Now there's two cases. I'm going to relate it with this. Now you need to tell me in which container will the pressure be greater? They're both identical containers. If I have, for example, there's less gas over here and there's more gas molecules over here.
The more.
Where do you think the pressure will be greater?
The one with more gas particles.
Yep. So what does that mean? If you have more gas moles being formed, if you have more gas being formed inside the container, then the pressure of the container will start increasing, right?
Yep.
And if you have less gas inside the container, or if you're forming less gas inside a container, then the pressure of the container will start decreasing. Is that correct?
If there's
So,
less, yeah, it'll
yep,
be less pressure than the one
that
with
will be
more.
less pressure. So pressure is
Yep,
caused by gas molecules hitting the side of the containers, right? Of the containers. The more molecules you have in the container, the higher the pressure will be, right?
yep,
Now, in order to decrease this pressure, what should equilibrium do? Should it form more gas? Should it form more moles of gas or should it form less moles of gas inside the container in order to decrease pressure?
less,
Less. And if you had a container at low pressure at equilibrium and you wanted to increase the pressure, what would equilibrium do in order to increase pressure? Would it produce more gas molecules or less gas molecules?
more.
More gas molecules, right? So that is why we're labeling over here that on going on which side do I produce more gas and going on which side do I produce less gas. So that later on, if I increase the pressure, I know which side equilibrium is going to shift. And if I decrease the pressure from outside, I do know which side the equilibrium is going to shift and which reaction is going to favor over the other. All right. So this is the working for pressure, just like we did the working for temperature, in which we labeled XO and O. In pressure, remember that it's only valid for gaseous phase reactions. And then after that, you need to know how many moles of gas are on the reactant side and how many moles of gas are on the product side. All right.
Yep,
So now let's discuss that. So you have A gaseous plus 2AB, so 2B gaseous. That goes into C plus D. Now the question says, what if we increase the pressure at equilibrium? So before reading the question, I just saw the word pressure and change in pressure. What am I going to do? I'm first going to do the working. How many moles of gas do I have on the left hand side? 1 plus 2, 3 mole gas, which means there's a 3 mole gas. And on the right hand side, how many moles of gas do I have? 2 mole gas, right?
yep,
So can I just simply say this side carries more gas and this side carries less gas? If I go on to the left hand side, I'll produce more gas. And if I go on to the right hand side, I produce less gas, right? In simple words. Now, if I've increased the pressure, now if I've increased the pressure, what is equilibrium supposed to do?
it's supposed to decrease the amount of
Yeah.
particles.
No, it's supposed to decrease the pressure. How it will do
Yep,
that, it's dependent again on the forward and backward reaction. So if
yep,
we increase the pressure, equilibrium will do what? It will try to decrease the pressure. And in order to decrease the pressure inside this container in which all these gases are present, which side should the equilibrium shift towards? Should it shift towards more moles of gas or less moles of gas? Yep. Should it shift towards the right hand side where there's less moles of gas, or should it shift towards the left hand side where there's more moles of gas?
the right hand side.
Yeah, the right hand side. So where is equilibrium going to shift? It's going to shift towards the right hand side, towards the fewer moles of gas, and then the pressure inside the container will start decreasing again. All right. So if we increase the pressure at equilibrium, equilibrium will shift towards the right hand side in order to produce fewer moles of gas so that the pressure decreases. All right. Or you could just write, if we increase pressure, equilibrium will shift towards the side with fewer moles of gas, which is the right hand side, in order to decrease pressure inside this container. Are we clear?
Yep.
So what should happen if we decrease the pressure at equilibrium? What would happen? So let's do that. Now in this reaction, if I decrease the pressure, so A plus 2B goes into C plus D. This was gaseous, this was gaseous, gaseous, and gaseous, right? There were 3 moles of gas on the left hand side and 2 moles of gas on the right hand side. That means more gas is produced when you move left and less gas is produced when you move to the right inside the container. All right. So if we decrease the pressure, what is equilibrium supposed to do? It's supposed to increase the pressure again. And in order to increase the pressure, would it produce more moles of gas inside the container or produce less moles of gas inside the container?
More.
More gas, right? Because more gas, more moles of gas would have more molecules of gas. More molecules of gas will apply more pressure on the walls. So the pressure will increase. So it will shift towards the left-hand side in this case, right? So I can write it as, if we decrease the pressure, equilibrium will move to the left-hand side towards more moles of gas in order to increase the pressure. All right.
Yep.
So that was all about Lechatelier's principle and the factors that affect equilibrium. All right. Now, what I'm going to do is, there's also another very big confusion about a catalyst. A catalyst never disturbs the position of equilibrium. It has no effect on equilibrium or position of equilibrium, but it does increase the rate of forward and backward reactions simultaneously or equally. We'll discuss that later, but before we go on to that, there's also another case for pressure. If you had a reaction like S plus Q gas form P gas plus R gas, and I ask you, what happens if we increase the pressure? What is going to happen over here?
Then it would try to decrease the pressure.
First of all, is this reaction affected by pressure?
Yeah,
Well, this
they're all
equilibrium,
gases.
yeah, this equilibrium is affected by pressure because it's a gaseous phase reaction, right? The second thing is labeling the number of moles of gas on either side. So you have 1 mole of this, 1 mole of this. How many moles of gas?
2.
2 mole. How many moles of gas on the right hand side?
2.
So there's equal moles of gas on both sides. Now tell me, if I've increased the pressure, what should equilibrium try to do? Decrease the pressure, right?
Yep.
And in order to decrease the pressure, equilibrium has to go to the side towards which there are less moles of gas. Is there any side over here, or is there any reaction over here in which there's less moles of gas being produced?
No, it's the same.
Yep. So then pressure again will have no effect on equilibrium, right? Because equilibrium cannot move over here. Either side, whichever side it goes on to, it's producing the same gas. All right. So if you have equal moles of reactants, gases, and equal moles of product gases, then then pressure will have no effect on equilibrium. All right. So let's write a note about that. This is right. No effect as the moles of gas on reactant side and product side are equal. All right. So equilibrium cannot move in any way to decrease the pressure. Okay.
Yeah.
All right. So these were all the factors. All right. And after this, what we're going to learn about is going to be our catalyst. Yep. I'll keep this very clear. So effect of catalyst on equilibrium. Remember that all the other factors were changing the equilibrium position. All right. But a catalyst cannot change the equilibrium position. It only speeds up the reaction. And in case of reversible reactions, it only speeds up the forward reaction as much as it has speed up the backward reaction. All right. That's the only role that it's going to play here. Clear?
Yeah.
All right. So the first most important note that you need to remember by heart and need to memorize this, that catalysts have no effect on the position of equilibrium. Position of equilibrium. So no shifts, no moving towards the right side or the left side. You can also add that Lechatelier's principle does not apply to them. It only applies to temperature, pressure, and concentration. Clear? Now, you can explain this by writing a reaction. For example, if you had this reaction, and this reaction was at equilibrium, for example, or let's say it took 50 minutes to reach equilibrium without a catalyst. Right? And the equilibrium is dynamic equilibrium. That means it's 50% forward reaction and 50% backward reaction. So in order to reach this dynamic equilibrium, initially it took 50%. Now, what does a catalyst do? What's the role of a catalyst?
It speeds up a reaction.
Yeah. A catalyst is a substance which my pen is not writing properly. Catalyst is a substance which increases the speed of a reaction, right? It increases the speed of reaction without being consumed itself, without being consumed. And later on, when we study rate of reaction, that's when I'll give you the real definition of the catalyst. But for now, it is only a substance which is going to help increase the speed of reaction. That means if previously it took 50 minutes to reach dynamic equilibrium, After adding a catalyst, it's going to take you half that time. It's going to take you 25 minutes. So you saved a lot of time. The reaction went to dynamic equilibrium a lot faster with the catalyst compared to without the catalyst. All right. So adding the catalyst does not move the equilibrium position towards the right or towards the left. No shifts in equilibrium position. The Lechatelier's principle does not apply to the catalyst. But what it does is that previously, if this reversible reaction took 50 minutes in order to reach this dynamic equilibrium, after adding a catalyst, the rate of the forward reaction would speed up. The rate of the backward reaction would also speed up by the same magnitude, right? So it's still in dynamic equilibrium. The rates are equal in both directions, but they're faster. For example, by adding a catalyst, this became 3 times faster. The backward reaction would also become 3 times faster. All right. They would stay in dynamic equilibrium, but that dynamic equilibrium state would be reached faster than it was reached without the catalyst. All right. So in the presence of catalyst, this took 25 minutes. So you save 25 minutes. That's all there is towards catalyst and equilibrium. All right.
Yeah.
So we can write an explanation. The catalyst does not affect position of equilibrium. It speeds up the forward and backward reactions equally. All right. So it speeds up the backward and forward reaction equally, due to which the reaction reaches equilibrium, due to which the reaction reaches dynamic equilibrium or the equilibrium faster. All right.
Yeah.
So that's all about the catalyst. Now we've done the factors. We know about the catalyst. We know about how concentration affects the reactions at equilibrium, at dynamic equilibrium. So now what I'm going to do is I'm going to do an example, and let's see how this reaction is affected. So let's do N2 plus 3H2 goes into 2NH3. This is the Haber's process equation. This is N2 gas, H2 gas, and NH3 gas. The first question would be, now the delta H for this reaction is negative. All right. Now my first question is, what if we decrease the concentration of NH3 at equilibrium? What should happen right now? What should equilibrium do? Now remember what workings you have to do. For concentration, it's just simply checking. So if I decrease the concentration of NH3, what should equilibrium do? Yep, it should try to increase. You always have to ask yourself this. Very simple. If I decrease this, what should equilibrium do? Write that down.
Try to increase it.
It will try to increase NH3. In order to increase NH3, which side should equilibrium go to? Towards the left-hand side, where NH3 breaks off and forms N2 and H2 gas, or should it go to the right-hand side, in which N2 and H2 react together and form more NH3?
The right hand side.
Yeah. So in order to increase this, the equilibrium will go to the right-hand side. So now you have to just write that in sentences. So if we decrease concentration of NH3, the equilibrium will shift towards the right hand side to form more NH3. All right.
Yeah.
What if in the same reaction I try to, what if we increase the temperature? What should happen then? Now for temperature, you know the working. What's the working for temperature? You have to label the exoendothermic reactions first, and then what happens to temperature. So the forward reaction in this case is what? It's exothermic.
Exo. Yep.
And the backward reaction must be
Endothermic.
endothermic. In exothermic reaction, the temperature of the surrounding would be increased, and the
Increasing.
backward reaction, it would be decreased. Now what have I done? I've increased the temperature. What is equilibrium going to do?
It's going to decrease the temperature.
Decrease temperature. In order to decrease the temperature, which side should equilibrium go to? Towards the right or towards the left?
The left-hand side,
Left hand side. So,
favoring the
yeah,
endothermic reaction.
exactly. So the equilibrium will shift towards the left hand side, right? So remember that the working for the concentration was separate. I'm just doing it on that so I don't waste time writing the equation again. So let's just write the equilibrium will shift towards which side? Towards the left hand side. And favor what?
The
Will
endothermic
favor
reaction.
the endothermic reaction in order to decrease temperature. Clear?
Yep.
And the last point, if we increase pressure, now I'm going to write the equation again so that we do not make a mess over there. So N2 plus 3H2 goes into 2NH3 and the reaction was negative, had a delta H negative. So now for pressure, what's the working for pressure? Do I label the reactions, endo, exo, or what do I do? I label the moles of gas in on the product and reactant side. First of all, I need to see, does pressure affect this equilibrium?
Yes, because they're all
Yep,
gases.
it's a gaseous phase reaction. Pressure will definitely affect the equilibrium. Now, the next thing I need to do is I need to see how many moles of gas on the left-hand side. Yep,
There's 4.
yep. So 4 mole gas on the left-hand side and 2 mole gas on the right-hand side, right?
Yep.
So if I move to the right, I make less gas molecules. If I move to the left, I make more gas molecules, right? So now, if we increase pressure, what is equilibrium going to do?
It's going to try to decrease pressure.
Now, in order to decrease pressure, should it form more moles of gas or less moles of gas?
Less. So move to
Less.
the right-hand side.
So it will shift to the right hand side towards less moles of gas. All
Yep.
right. So now I can write it like this. So equilibrium will shift towards the right hand side towards the less moles of gas in order to decrease the pressure. Very clear.
Yep.
And the last thing, what if I add more catalyst? What should happen? Where should the equilibrium position shift if I add more catalyst in this reaction? Yep.
It would just be like faster, no?
Yeah,
Like time taken would be faster.
exactly. The catalyst has no effect on the equilibrium position, right? So it will not shift to any side. What it does is that if this reaction reached dynamic equilibrium in, for example, 1 hour, it's going to decrease that time by increasing this forward and backward reactions equally, their rates equally, right? So no effect on position of equilibrium, no effect on position of equilibrium. Catalyst only speeds up the forward and the backward reaction equally. So equilibrium is achieved faster. Clear?
Yep.
So this was Lechatelier's principle and all the factors that affect equilibrium and how the catalyst can never affect the position of equilibrium. It only makes the reaction or the reversible reaction reach equilibrium faster. So are we clear?
Yep.
Okay.